Frictional generation of electricity is always obtained when we have particles that are bumping into each other, such as raindrops in clouds, wheat in silos being poured out. And this is another good example. This device here was brought out to New Zealand in 1925 by Ernest Rutherford doing a lecture tour. And he used this as an example of the different colours that atoms give out under electrical discharge. But he produces electrical discharge mechanically. There's a little pool of mercury in each of these spheres and a low pressure gas, different coloured gases. And when these are shaken around, drops are formed, frictional charging happens, there is electrical discharge between different drops, and the gas glows with the colour of the gas inside that bulb. Here's a modern version of that device I've had made up. Just a spherical glass flask, some mercury put into it, the air pumped out, filled with neon gas, and then that pumped out until the pressure is right for the maximum light output. Now, neon is the gas used in red advertising signs, hence red neon lights. If we shake this now, you can see the droplets breaking up, separating. They're fractionally charged compared with their other drops. There is discharge between oppositely charged drops, and the gas glows very weakly, can only be seen in the very darkest conditions. This is another simple device I've had made up. Again, you can make it yourself if you can do a little bit of glass blowing, just any piece of glass really. Some mercury poured in, pump the gas out, backfill with neon gas, and then slowly pump that out whilst shaking until you get the maximum bright light. Now this one I've put two necks in here, and so just by reversing you can see we break the column up into disjointed pieces of mercury. They get frictionally charged. There is gas discharge tube. There is gas discharge between these, causing the gas to glow red. This requires a darkened room to be seen. In 1893, Ernest Rutherford started his research career at Canterbury College in New Zealand. He set himself the task to determine whether iron was magnetic at very high frequencies. Now, why did he do this? Because Nikola Tesla was in the news with his high voltage, high frequency step-up transformer, saying that this was a way to transmit power without wires. And everyone knew that transformers were more efficient if they had an iron core, and that is what stimulated Ernest Rutherford. And here is a Tesla coil. The principles of this Tesla coil are as follows. Down at the bottom, we have a high voltage transformer, such as used in neon tubing advertising signs. That and some spark gaps puts quite a high voltage oscillating at several hundred kilohertz onto this coil of a few turns. That in turn induces into this coil, which has many, many more turns, so a voltage that is magnified up by the turns ratio until we have enormous electric potential up the top here of several 100,000 volts. That is high enough to just rip electrons off atoms. And so we will get a gas discharge, we will get a lightning bolt. And this is quite spectacular. Let's have a look at that now. The sparks around this showed that there were extremely high electric fields around this dome. And we can actually look at those using fluorescent tubes, just having a potential difference along the tube, and they will light. Let me demonstrate that now. White light tubes are all very well, but why not use something nice and colourful such as the boy racers put on their cars? These tubes are readily available from any car store. Let's try them now. That was much more colourful, wasn't it? Now, if we bring an earthed rod up near this sphere at full charge, we'll be able to concentrate all of those sparks into one really concentrated one. Let's have a go at that now. That spark shows what an enormous electric potential this sphere has been raised to when it's operating its highest. Hundreds of thousands of volts. Only an absolute idiot would go and touch this thing when it's at its highest potential. Or by someone who knows what they're doing. What I used there was a butcher's glove, metal mesh, to distribute the discharge points all over my hand. If I just used my bare hand, initially there would have been a single spark across it which would give me such a shock I would have pulled my hand away automatically. And it's very difficult to force your hand forward against that. Of course, don't ever do this unless you really do know what you're doing.